All right, welcome to Be Explainer, where our whole thing is taking documents and turning them into compelling stories. And today, we're going to deconstruct an entire career to see if we can find a real-world blueprint for what high-impact work actually looks like in the 21st century. I mean, think about it. What does that even mean anymore? Is it about being a super specialist, going a mile deep and an inch wide in one narrow field? Or is it something else entirely? We're going to explore this idea of building a career that's got both incredible depth and a really broad reach. And you'll never guess where we found a potential roadmap for this. An unexpected place for sure. A CV. Yeah, you heard me right. We're going to break down the curriculum vitae of one individual, Dr. Sameh Tawfiq, because his career path is this absolutely fascinating blueprint for what you might call a modern polymath, someone who truly masters and then connects fields that on the surface seem to have nothing to do with each other. So here's how we're going to follow this map. We'll start by painting a portrait of a modern engineer, then dive deep into his time as a master of the seas. From there, we'll see his pivot to innovating for clean energy and then explore how he shares his knowledge to shape minds. And finally, the best part, we'll connect all the dots to understand the real power of synthesis. Okay, first up, let's talk about the practitioner. This is the hands-on real-world stuff, where the rubber meets the road. Or, in this case, where the steel meets the sea. We're heading straight for the engine room of some seriously massive vessels. So to get the scale of this, you have to understand the machine he was working on. Dr. Tawfiq worked on what are called ro-ro vessels. The easiest way to picture one, think of a giant, floating, multi-story parking garage. These things are absolute titans of global logistics, and they are unbelievably complex systems. And in 2012, he reached the absolute pinnacle of this maritime career. Earning the certificate of competency as chief engineer is, well, it's way more than just a promotion. It is a declaration of complete mastery over every single mechanical system on what is essentially a floating city. And the scope of responsibility that comes with that title is just immense. We're not just talking about engines. It's everything. The life support, the refrigeration, the HVAC, managing a huge crew of engineers, all while making sure you're following these incredibly strict international safety codes. And oh, by the way, you're doing this 24/7. This is high-stakes, hands-on engineering at its most intense. So you might think, okay, he's reached the top of his field as a practitioner. Story over. But this is where things get really interesting. He pivots. He moves from the organized chaos of a ship's engine room to the quiet of a research lab. You see, running parallel to this hands-on career was a decades-long academic journey. It starts with a bachelor's degree way back in 1991, and it all culminates in a PhD in 2016. And his specialty? Something called biogas sweetening and fractionation. In simple terms, it's the science of purifying biological waste and turning it into clean fuel. It just couldn't sound more different from maritime mechanics, right? So he pointed that brilliant engineering mind of his at one of the biggest problems in sustainability. How do we take all this organic waste, garbage, agricultural stuff, and transform it into high-purity methane that can actually power our homes and cities? And this table perfectly illustrates how his focus evolved. You see, in 2015, he's working on getting the absolute highest methane purity from biogas. Jump to 2022, and he's applying thermodynamic principles to literally pull drinking water from thin air. And then looking ahead to 2025, he's tackling the efficiency of liquefied natural gas, or LNG systems. And boom, LNG. There's the direct link right back to the world of maritime energy. The threads are starting to connect. So if we wanted to simplify his PhD work, it kind of looks like this. You collect a bunch of organic waste, then you use special chemicals to absorb all the impurities and gunk like CO2. The real magic is in step 3, optimizing the pressure and the chemical absorbers to get it just right. The results? You get a clean, high-purity methane fuel. It's like solving an incredibly complex chemical puzzle, but one with huge, real-world implications. Okay, so we've got the practitioner and the researcher, 2 incredible careers right there. But there's a third absolutely crucial pillar to this story, the drive to share that knowledge. He's not just accumulating expertise, he is actively pushing it out into the world. And his teaching isn't just stuck in one classroom. I mean, look at this. He's a university professor, sure, but he's also an international consultant for training centers. He's involved in major community initiatives, and he even gets on public media to talk about this stuff. He is spreading his knowledge far and wide. And check out the kind of knowledge he's sharing. This is not intro to engineering.
He's developing and teaching these highly specialized, internationally certified courses on everything from cryogenics and gas liquefaction to human factors engineering. He is directly shaping the future of the entire maritime industry.
And then there's this, which is just a fascinating contrast. The same mind that designs courses on natural gas processing also delivers training for Mawada, an Egyptian presidential initiative focused on strengthening families. That shows a deep commitment not just to technical systems, but to social systems too. And when you contribute on this many levels, people take notice. He received this medal for excellent long duty and meritorious service from the highest levels of the Egyptian armed forces. This is a huge deal, a lifetime of service being recognized on a national scale. So we've seen the engineer, the scientist, and the educator. Now for the final step, putting all these pieces together. How do they connect? What does this whole picture actually tell us? I mean, is this just a collection of impressive but separate achievements? Or is there a deeper logic at play here? A common thread that weaves its way through the engine room, the laboratory, and the lecture hall. The key insight is that these roles aren't separate at all. They are a feedback loop. Think about it. The real-world problems he faced as a chief engineer directly inform his academic research into making energy systems more efficient. The deep scientific principles he explores in the lab allow him to create richer, more practical training courses as an educator. And the challenge of teaching complex ideas forces him to clarify his own thinking, which in turn sparks new avenues for innovation. Each role makes the others stronger. And that's the common thread. It's a fundamental drive to understand how systems work, whether they're mechanical, chemical, or social. It's a relentless desire to optimize those systems and make them better. And it's a core belief in the importance of sharing that knowledge to empower others, to build, to improve, and to share. And this leaves us with a final big question. In our world, we often celebrate the hyper-specialist, the person who goes deeper and deeper into one single topic. But this career shows us that maybe, just maybe, the greatest impact comes from the synthesizers, the people who build bridges between disciplines and apply knowledge across all kinds of different fields. So you have to wonder, in a world full of specialists, what could we achieve with more synthesizers?